there's two things they might ask you to do with this kind of problem. They might ask you to either evaluate it, or they might ask you to simplify it. So to evaluate this problem means find the value of, and all you have to do is punch into your calculator, 437 to the 1/5 power. Or you might have a calculator that has the 5th root button or the nth root button on it, but that's basically how you do it, and then it'll give you an approximate answer if it's not exact. If you want to simplify it, that's a different problem. To simplify it, I always teach people to do it like this. Take 437 and break it down into its prime factorization. So just break down as much as you can 437. And it might not even break down any, but try to break it down so it's not divisible by 2. Add up the digits to see if it's divisible by 3, which it is not because they add up to 14. It's not divisible by 5, nor 6 because it's not even 7. Try 7.
I'm pretty sure it's a prime number.
Yeah, it might be prime. Is it divisible by 7?
No.
Or 8, or not 8? How about 9? Not 9, 10, 11, maybe 11?
Nope.
Or 12, not 12, 13, try 13. It's not divisible by 13. And at some point you don't have to keep going because 13 times 13 is 169. I guess we have to keep going a little bit, but the chances are it's not going to be divisible by anything else. So keep going. 17, no, 19.
It's divisible by 19.
Okay, it's divisible by 19, so it's 19 times 23. That doesn't help us because both of these are prime. So there's nothing we can do to break that down more. What we would be looking for is 5 of the same root. When we look at our factor tree, like look at 64. 64 is 2 times 32, which is 8 times 4, which is 2 times 2 times 2 times 2 times 2. And you can see that there's 5 2's. And so a 2, because it's a 5th root, a 2 is going to come out, and then this stays in because there's only 1 2 left over. So the simplified version of 5th root of 64, for example, is 2 5th root of 2. And that's how you would do it if you were to do it. But sometimes you get these humongous numbers, and it's kind of hard to find the factor tree for them. But that's the difference between evaluating and simplifying a radical.